Okay, if you look at the Intro to Parabolas worksheet, this one's really short, but there's some important things on there. Okay. You see 4 graphs representing quadratics. The shape of a quadratic graph is always that U shape. And that shape has a name. The name is parabola. So the graph of a quadratic is called a parabola, just like we have circles and squares and triangles. That shape is a parabola. And not every U shape is a parabola. You'll notice that parabolas start kind of not very steep and they get steeper and steeper as you go up. Well, if you had one that, let's say, had these straight lines and then curved and then a straight line, that is not a parabola. Because parabolas are always changing steepness. Okay? Likewise, if you had a U like this, that is not a parabola, because parabolas are never straight up and down. Yes? No. And that's interesting. So, this parabola over here will never be straight up and down. But the slope is always increasing. So here it might have a slope of 1, and a slope of 2, and a slope of 3. And the further out you go, a slope of 1,000,000, a slope of 10 million, but it will never be straight up and down. Kind of, yeah. Yeah, it's kind of like the opposite of an asymptote. Well, I guess you could call it an asymptote. But yeah, same idea. Because you can always plug in another x, right? If the graph were to go straight up and down, then that means that like x equals 4, there's no graph there. But that's not true. You can always plug in another number. So in that lawn mowing story, is there any limit to the end of when you can mow the lawn? Well, according to how much money your uncle has. But in theory, could you plug in 1,000,000 weeks? Yeah. But how steep is the graph going to be at 1,000,000 weeks? It's almost vertical, but it will never be vertical. It's always moving to the right and getting steeper. Good. Those are good questions. But parabolas have this really cool quality that no other shape has. Parabolas have a point on the inside that's called a focus. And there are parabolas in this room. There are parabolas at your house. Okay? My glasses are 2 parabolas. So what you do is the front part of your lens is a parabola. And if the back part of your lens was the same parabola, then your glasses aren't going to have any sort of prescription to them. They'd just be like regular sunglasses. But if my front parabola is less steep than my back parabola, so let's say that's a cross-section of the lens, when the light comes in, what's going to happen to it? It's going to go out. So it goes in like this, and then it comes out like that. So apparently, my eyes, because of bad genetics, my focal point on my optic nerve is too close to the front of my eyeballs. So what my glasses do is spread the light out a little bit, and that brings, it's like bringing your optic nerve back. And I can prove it to you. Can you see the light has been spread out? So it looks like they're kind of sunglasses, right? Does that mean they're not see-through? No. This dark point, I've taken the light in the dark point and I've spread it out, and now it occurs over here. So when you get old, so you know how you can focus your eyes? Well, you have muscles that will change the shape of your cornea. They will change the shape of your lens. And, hold on a second. Okay. Well, when you get old, your cornea doesn't stretch like it used to. So when you're across the hall and you see Moss pull out his glasses and put them on, it's because he can't see up close. He can't change his cornea to the point where it will work. So I did. And I got proof on video. So if you have reading glasses, they're different. You have a front lens, but the back lens is going to be less steep than the front lens. So it would look like this. And what is that going to do to the light? It's going to push it in. So you could take an old person's reading glasses and go burn ants with it. Because it doesn't scatter light, it condenses the light. Now, it depends on how strong their prescription is. But, yeah, the little thin ones, yeah. Yeah, those will take light and bring it down instead of spreading it out. So, it won't matter. So whether it's that way or that way, it's the same. Yeah. So my glasses scatter light, but reading glasses are like little magnifying glasses, and they condense the light. And you know, people with bifocals, they have bad eyes like me, which scatter the light, except they're old, and their eyes don't work very well, so at the bottom they have magnifying glasses. And that's all it is. It's like taking this portion here and moving it over and sticking it on those glasses. So the top part scatters, and the bottom part condenses. And so that's why they put the bifocals at the bottom, and old people read like this. Yeah. Okay? Well, there's another place that you see parabolas. Many of you on your house have a satellite dish. Or you'll see towers with satellite dishes on them. Satellite dishes are in the shape of a parabola. And all they do is take a signal, and the signal comes in, and they focus that signal on the receiver, and the receiver is actually pointed at the dish, not at the satellite, because these rays bounce and they hit that focus. And a parabola is the only shape that will do that. So you can take a weak signal and you can concentrate it down. I saw a video once of a guy who had a mirror, a parabolic mirror that was about this big, and he set it on a hillside on a sunny day. He got a long stick with lead on it, and he stuck the lead out there at the focus, and the mirror melted the lead. It used the sun to melt the lead. It was pretty cool. Have you ever been to one of those science places that has the big, huge dishes? Like there's one 100 yards away, and there's one over here, and you can whisper into one. And if you put your ear at the focus, you can hear a whisper on the other side of the football field or whatever it is. Have you ever watched sports on TV, especially football, and there's somebody on the sideline holding a stick with a big plastic clear dish on it? All that is a parabolic microphone. And you can aim that microphone wherever you want, and it takes this much sound and condenses it to a single point, so you can listen to the huddle from the sideline. If you point. Yeah, or they mic them, one of the two. Because those guys that are on the sideline don't work for the teams, they work for the league, and then they use those to make videos. So it's not like a coach can listen to the thing. That's against the rules. So parabolas show up all over the place. Okay? Let's talk about some of the parts of a parabola. So the first part we're going to talk about are the zeros. In that first parabola, you see a lot of zeros. But when we say the word zero, we mean, so a zero is called the x-intercept. That's the answer to number one. The x-intercepts are called zeros. And those are the most important things about parabolas. We're going to study lots of parts of parabolas, but zeros will come up the most. Where does the graph cross the x-axis? So back in the pig story, one of the zeros was 8, because that's when the pig ran out of food, when it had 0 barrels left. Were there any zeros in the lawn mowing story? No, because he never had no money, right? When the story began, he was given $2 and then paid every time after that. Okay? These zeros are also referred to as roots. And I will use those three terms interchangeably. You will probably hear me say roots most often. All right, the second one asks, the vertex. No, y-intercept is just y-intercept, and we don't deal too much with that as much. But a vertex is a corner. Does a circle have a vertex? No. Does a square have a vertex? Yeah, all polygons have vertices, and it's where the shape changes directions. Where does the parabola change direction? This kind of the center, yeah. That would be called a vertex. All right, what else did you notice about the shape? Is there anything about the shape that happens every time? Oh, good. Let's look at, if we go back to some of these charts. Oh, no, don't tell me I got rid of them. Okay, right here. Do you notice anything, any other pattern than the -2? It's kind of a mirror image, right? If I draw a line splitting the positives and the negatives, the numbers are the same. And that's also true here. See, we have a 9, 8, 8, 5, 5, 0, 0, 7, -7, -7. So in a parabola, the right side and the left side are exactly the same. Whenever a shape has the same right and left side, we call that, what's the word for a shape that's symmetrical? It's symmetric. So parabolas are symmetric, meaning you're not going to have a left side that looks like this and a right side that looks like that. That is not a parabola. It doesn't have that reflecting quality or refracting quality. Okay, that one's done.